everyone. So in the previous tutorials, I talked about text-to-points and also how to create a morphing effect using text-to-points. In this tutorial, I am going to talk about how you can combine text-to-points with classes and objects so that you can remove different points along the text. So let's take a look at how that might look like. In here, I'm using text-to-point in combination with JavaScript splice so that these little bots agents that I've implemented into the sketch can move around and actually begin to remove different parts and areas of an alphabet. So in order to achieve this effect, I'm actually going to start from a simple sketch here, going to be included in the description of the video. And what I got here is a custom grotesque font in OTF. I have translated the vertices inside the alphabet using text-to-points, and I am drawing them out using rectangles inside a for loop. So the task we have right now is to combine what we have here with class and objects so that once we begin drawing, we can start thinking about how to remove some of the objects along the text. So what we gotta do now is first creating a new class. I'm going to name this class alphabet. And inside of the class, we need to start with a constructor. So I'm gonna write constructor. And inside the constructor, there's gonna be two variables. And it's gonna be this.x equals to x, this.y equals to y. By the way, if this all seem unfamiliar, please check out my classes and object tutorial where I go more in depth into how this syntax works. However, I'm going to move forward. And here, as you can see, I'm stating a variable, x and y, which needs to be passed through the constructor. So here, I'm going to declare variable x and y for my constructor. Okay, so we got a basic skeleton form for our class. What we gotta do next then is actually going up to our global variable, and actually I have something here that I'm gonna replace. It's just going to be let alphabet equals to an empty array. And now I can actually bring my objects from the class alphabet into the world using setup. And so what I'm going to write now is right under text-to-points, I'm going to create a for loop. So the for loop is going to say for let I equals to 0, I smaller than alphabet array 1 dot length. What is alphabet array 1 dot length? That is actually referencing this variable on line 16, right? So what that is actually recognizing the number of existing vertices that has been translated and converted using text-to-point of the letter M. So I'm gonna borrow the length of my vertices and I++. So then, once I have this, essentially defining like the number of objects we want to create along the letter, I'm now going to say, I think my variable was called alphabet, right? Alphabet square bracket I equals to new alphabet. So what is this going to do? Line 19 is that it's going to create multiple new objects of the class alphabet. And it's going to, the amount of object it's going to create is going to match the items inside of my text-to-points alphabet array 1. Okay, now, remember we have to pass the x variable and the y variable through this parenthesis here so that it's going to get sent into the constructor so that it knows, every time it creates a new object, it's going to, sit right along the positions of the text-to-point vertices x and y. Okay, so that's going to look like alphabet array 1 I dot x and alphabet array 1 I dot y. Okay, this is great. So now we are going to create an array of alphabet objects, and inside of that, each of the object is going to have a different x and y following the instruction generated from text-to-points. Okay, so that's good. We're not, okay, I'm gonna disable this because we don't need this anymore, or need to move it, right? So I'm gonna disable this for now. If I hit play, nothing is going to happen because we need to create a new function inside of our class in order to draw each of those rectangle out. So here I'm gonna write show, and I'm going to say rect, and it's going to be this dot x, this dot y, and the size, is arbitrary. I'm just going to do 10, 10. Nice. And so therefore, when I want to draw my alphabet objects out, I just have to go into my for loop inside of draw. We're still drawing the same amount of alphabet array items, except now we're actually drawing it through the class alphabet and the object that's being produced through that. So here I'm going to write alphabet I dot show. Okay, moments of truth. Let's hit play. Okay, there you go. So we just successfully integrated the alphabet class and the alphabet objects into our text-to-point system. So that's great. Step 1 is complete. Now we gotta think about how we can integrate a bot into, or multiple bots into the sketch. So as I move around and begin removing the borders of my M, right? Okay, so that's exciting. I'm going to actually make a new class for the bots. I'm gonna call it bot, and here it's again going to have a constructor, and I'm going to make the bot kind of appear in random position. So I'm going to write this dot x equals to random. I'm going to state the range is going to appear on the x-axis, which I've already I've figured out ahead of time. So it's going to be a 140, 150. Actually, it's pretty small range. And the next thing I'm going to do this dot y, again, random between 200 and 220. Okay, so now we have a class bot. The class bot is also going to show up on the screen. So we need a show function in here. And it's going to be a rectangle. And it's gonna use this dot x, this dot y, and I'll just say maybe it's just half the size of the actual border. So it's gonna be size 5 pixel by 5 pixel. Okay, so let's make the bot show up first before we make it move, just to make sure we're on track. So here I'm gonna come right back up, and I'm going to say let bot equals to an empty array. And now, again, we have to come into setup, essentially just replicating the process a little bit, and say for let I equals to 0, I smaller than, now it's like how many bots do we want to create? What if we create 5? And I plus plus, cool. And now we have to say bot I equals to new bot. And again, we have to come in a draw. So always the kind of like most straightforward way to write classes and object, in my opinion. Copy this for loop line that we just wrote, line 23 to 25, and we're gonna come down here, put it inside of draw, and we're going to delete everything, including the equal sign on line 39. I'm gonna write dot show. Okay, so let's hit play. And there you go. We see those 5 little bots showing up on the screen. They're very cute. And now the next thing we have to do is to make it move. So let's do that by adding a move function inside of class bot. So here I'm gonna write move. And okay, let's think about this for a second. We want the bot to move in one direction, and once it hits something, it's gonna bounce back towards the opposite direction. Okay, so here's what. I'm gonna begin, before dealing with the borders, I'm gonna begin by saying, or making it the case so that when the bot hits the edge of the canvas, it's going to return. So it doesn't just like flow away and never come back. So we're gonna start from there. So I'm gonna write this dot x equals to this dot x plus this dot direction. And of course, we don't have that variable yet. So I'm gonna come back up to my constructor and say this dot direction equals to random -1 and 1. So it's either going to move, you know, in the positive direction or into the negative direction. All right, and we have to do one for y as well, because we're not, you know, so that has like more dynamic possibilities of moving, like, you know, positive y, negative x, and vice versa. So here I'm gonna write this dot direction 1 equals to random -1, 1. All right, so here I'm going to say this dot y equals to this dot y plus this dot direction. Oh, sorry, 1. Okay, so here, remember we're just doing the edges first, so I'm going to write some if statements to make that happen. So I'm going to say if this dot x is bigger than width, then this dot direction equals to minus this dot direction. So if this dot x hypothetically is moving in the positive direction, as long as it hits the width, it's going to get bounced back to the opposite direction. We need to like add another possibility though, because it's possible that our x can be moving in negative direction. So if it's smaller than 0, we want it to bounce back as well, right? So here I'm going to say or this dot x smaller than 0. And I'm going to replicate the exact same thing for our y member variable. So if this dot y is larger than height, Or if this y is smaller than 0, this dot direction 1 equals minus this dot direction 1. Okay, so now all we have to do, we have added a additional behavior to our class bot, and what we have to do to like load it is just going into our for loop and say bot I dot move, right? So if we hit play here, you're gonna see, yeah, these bots moving in all different kind of direction, and it's gonna bounce back. Okay, awesome. That's great. Doesn't yet achieve what we need to do, so that's the next step for us. So this is maybe the trickiest part, the next step, right? Like how do we make sure that these two classes are communicate with each other, and one object can recognize the other sets of objects, and they can, something can happen when they collide. Under class bot, I'm going to add one more, an additional set of behavior. I'm going to call it collision detection. Okay, so inside of collision detection, let's think about this for a second. How can we find out whether a bot is going to touch one of the boxes around the border M? I guess there are maybe like 2 or 3 different ways to do it, but the most straightforward way is using the P5JS function dist, which stands for distance. So, so here's what I'm going to do. I'm going to add a new member variable. It's going to be called this.d. So this.d is going to be a variable that every single bot object is going to have. And this variable is going to constantly log its distance, the distance between it, the bot object, with like every single one of the boxes along that M letter. So now we have to write some code to detect the distance between this object versus every single box around that letter. So I'm going to write a for loop to do that. For let I equals to 0, oops, I smaller than alpha bet dot length. So we're loading and accessing the length of our alphabet object array, and I plus plus. Okay, and inside of this, I'm going to say this.d equals to dist. And that's the syntax here, right? So the way dist syntax work is that it takes 4 different variables. So this takes 4 parameters, which is x1, y1, x2, y2. So 2 different points on a canvas, x1, y1, x2, y2. This function helps us calculate the direct line between these 2 points and know how long they are, basically. Okay, so this is kind of the tricky part. The x1 is going to be, let's see, the x1 is going to be alphabet I dot x. So we're essentially like detecting every single object under the alphabet class and finding its current x position at every frame. And then it's going to be alphabet I dot y. So that's our x1 and y1, right? So it's this bot, the x and y position for this bot versus the x and y positions for like every single boxes around the M. And so second set is going to be this dot x, this dot y. Let's do a quick test just to make sure that this is working. So I'm going to say console.log, and whenever it touches, or sorry, oh no, I'm actually going to do console.log and do this dot d, which might really slow down the sketch, by the way. So let's just see what happens. I'm going to hit play. Oh, wait, I made a mistake, which is like I haven't loaded collision detection yet. So let's go back to our draw and always remember to write your function into your draw. So bot I dot collision detection. Okay, I'm gonna hit play now. Uh-oh, collision detection is not a function. Maybe there's a misspell here. Oh yeah, so detection. So you can see that the numbers are coming in. It's certainly detecting these numbers. It's moving very slowly because what happens when you use the this function and trying to load it, you know, like with such a large amount of boxes, so you're like detecting at every frame, is that it kind of like really slow the browser down when you're trying to like log it in your console. So, but at least we know that it has worked, right? It was able to detect these numbers, distance between the bot and every single boxes around it. So what we're going to do is, the goal here is that when the bot gets too close to any of the boxes around the letter M, it's going to just flip direction, correct? So that's what we're going to do. We're going to say if this dot D smaller than 5 pixels. So whenever the distance between the bot and one of the boxes gets closer than 5, then this dot direction is going to get flipped. This is our y direction here, by the way. And this dot direction 1, which is our y position, is also going to get flipped. So whenever it hits something, it's going to just sort of like move in its like polar opposite direction. Okay, so let's hit play. Woohoo! So what we have right now are these bots that essentially get stuck in the letter M, and it's gonna bounce back and forth forever. You know, whenever it hits the border, it's going to know to return. We're gonna take this one step further by using the JavaScript splice and remove the border that's blocking the way. So this is how we are going to do it. Whenever the distance is smaller than 5 pixels, not only is the direction and the direction 1 going to flip, but also we're going to splice that specific block that's hitting away. Okay, so what we have to write here is alphabet dot splice, right? Because we're splicing, we're removing an item from the alphabet array, which contains all of the objects around the alphabet. And so here, in terms of like what you write right here, the first item, the first parameter that you insert inside of the splice is indicating the position, the index number of the object you're hoping to remove. So we cannot put in like a hard number here, right? Like it needs to be like that specific box that it's touching. So in fact, we're gonna put I, right? So remember, we're working with a for loop. So essentially, it's testing the distance between the bot and every single boxes along the alphabet. It's just testing it so fast that it seems like, it's all happening at the same time, but it's a step-by-step process. So we're removing that specific box, which is I, and that has came too close. And the second parameter is the amount of item you want to remove from the array. And in this case, it's just 1. Okay, so if we hit play here, whoop, aha, so this is interesting, right? So we remove we remove the item there. We remove the item like successfully, but something happened, which is a kind of the way our show is written is, it breaks our show basically. So why is that happening? It's because over here on line 32, we were using the alphabet array 1 length, which is like referencing the text to point length, which, as we're removing objects from the alphabet array, it actually begin to mismatch, right? So over here, we actually need to log the alphabet dot length and not the alphabet array length. So if we change that, it would not have a problem anymore because it wouldn't try to load, boxes that have essentially been deleted. So I hope that all this makes sense. The next things you can try is to see if you could use the alphabet.splice feature in JavaScript to add and replace the shapes around the alphabet. I'm going to include example sketches to show you how to do that, and good luck.